All right. So a couple things off the top. Where are we at here? We've got this fourth pack back assignment, which was set to be due at the end of this week on Friday. So when it synced up to Canvas, there was some confusion. It was showing zeros in the grade book. They've got that fixed, but I think some people reached out and thought that meant it was due Friday. It was not. It just put the zeros in there. I'm not 100% sure why it synced up and did that, but I've corrected it. So just in case that caused confusion, I'll extend the due date to be on Monday of next week. So a couple extra days, just in case you thought that assignment was closed down over the last few. I think that's fair. So the sync issue is your guys' gain, although get on and get that done very early this week if you haven't already got it done. Kind of effort-based point, talking about monopolies, try to get that out of the way. But you'll see that due date change to be, instead of the end of the day Friday this week, the end of the day next Monday. Okay, so a couple extra days, although hopefully you don't need it, right? Other than that, I also put up on Friday, if I can get out of the way here, on the YouTube channel. I don't want to listen to myself. Oh, where is it at? So there's this additional Monopoly example that I put up, and I said, I think I mentioned it on Thursday, but basically the cohorts behind you are probably going to get a little more Excel in this class, or at least that's the desire of Kelly, and not just this class, but all classes. So, I'm trying to provide you some additional resources. So maybe you're just as competitive with the people kind of coming up behind you. If you haven't looked at Excel before, I try to talk through it as though you have no knowledge. But it's just showing you how we can do what we talked about with perfectly competitive and monopoly, specifically firms. You had a demand schedule, like prices and quantities and their costs, how you could solve profits, solve this profit maximizing point is, and doing this in Excel. So kind of giving you a couple of Excel skills, but also how do you take Excel and use it for some of the things that we're doing in this class. So that example is up there. I'm not going to ever quiz you, test you on Excel. It's just an additional example. If you have some Excel knowledge, maybe this will help make things make a little more sense that we've talked about. Okay. All right. Other than that, we've got this week. So game theory, like oligopoly markets. Next week, monopoly competition. We'll have a week of review, and then finals. Right. This final, I believe, is Monday night. So we're getting close to the end here, right? Really 3 more weeks. Basically, what? 3 weeks from today, or no, 3 weeks from yesterday is the final, right? So we're kind of rushing forward here. I'll get up a practice final exam. If I don't get it up later this afternoon, definitely tomorrow, you'll see that pop up. I'm not expecting that you start looking at it yet, but if you want to, I'm kind of getting out that since I've got it done, getting out there a little bit early. Okay. Any other questions for me before we jump into material here today? Try to go kind of quick so we can save ourselves some time on Thursday for some stuff too. So we are going to start out, we're thinking about oligopoly markets. So an oligopoly just means few. Actually, I think that's what the Greek is, like few or small number. Basically, we're looking at markets that aren't a monopoly. There's not one firm, but there might be 2, 3, or 4. All the models we'll talk about today and primarily focus on are going to be 2-firm models. You could take the same sort of principles and apply it to 3 or 4 firms. The math is going to be a little bit more complicated, right? So we'll kind of stick to 2, but here we're thinking about oligopoly markets. So somewhere in between a monopoly and a perfectly competitive market. Okay. So one thing that we're going to use in order to analyze these markets is something we call game theory. So game theory, we'll use some definitional things like we're identifying things like Nash equilibrium, dominant strategies. So all we're trying to do with a Nash equilibrium is understand, are the people involved best responding to what the other person's best response is? So is firm 1's response the best response to what firm 2's best response is? That's the definition of our Nash equilibrium. We'll have plenty of examples here today. So if you haven't seen, has anyone seen A Beautiful Mind? A couple people, no one in my last section, so they saw it. It's a pretty good movie. So it's based off like the real story of the guy that like came up with I shouldn't say the very basics of game theory, but like revolutionized it. Really good movie, kind of a crazy plot twist. but it's based off his real life. If you haven't seen it, highly recommend it, right? So they'll talk about some of the things that we talk about in this class, right? So what are the basics of game theory? So we're going to have players and rules. So for us, we're just going to keep this at 2 players, 2 firms, 2 individuals, 2 countries, right? Just two players, okay? Now, today we're going to focus only on simultaneous decisions, but when the decisions are made also kind of defines our game. So next class, we'll focus more on sequential decisions. I make a decision and then you do, right? So simultaneous as we make it at the same time. I always use examples like, let's say I'm standing, I don't know, blindfolded, 2 people, or someone's standing in front of me, and someone says go. We both have to make a decision at the same time to either go right or left. Well, what do we definitely not want to both do? If we both go right, we're going to hit each other, all right? So we have these strategy choices we can make to go left or right. We're then going to have the resulting payoffs. If we both go right, bad payoffs, right? If we both go left, bad payoffs. If I go right and the other person goes left, we didn't crash into each other, right? Good payoffs, right? So we have these different combinations of strategy choices, but if people can't see what the other person is doing, so I'm using this dumb example of stepping left or right, but what if it's setting prices? What if it's setting the quantity that we produce, right? If I can't see what the other firms are doing, we're making these decisions simultaneously without any information from the other person. These are the games that we're going to be thinking about, right? So we've got 2 players. We'll keep it kind of simple. I think next class, I might show you an example where there's more than 2 strategy choices, but for the most part, I'll just give you 2 strategy choice games. At the most, I would ask you to do like on a quiz or something would be 3. You'll see it's not that much more difficult than doing it with 2. And then from those different combinations of strategies, what are the payoffs that are going to exist for both of the players involved? Okay. So usually we're going to do this with a normal form game, especially when we have simultaneous decisions. Once we get to sequential decisions, we'll do these decision trees, but that'll be kind of on Thursday's class. Okay. So I've got 2 firms. Those are my 2 players in my first example. And let's say they have 2 strategies. Now, obviously, in real life, you can set a bunch of different prices, but this will get at the idea of, do I kind of go from price 1 that's higher or price 2 that's a little bit lower? We kind of carry that same idea if we had multiple prices. Okay? So high and low price are my strategies. And then the payoffs will be, well, think about it this way. If we both set high prices, what's that going to do to the quantity sold in the market? It's going to go down, right? We both set low prices. What's that going to do to the quantity in the market? It's going to go up, right? What if one person sets a high and low? Well, everybody's going to buy from the person that sets a low price. So we're going to have different quantities sold, different prices that are going to result in different profits, right? So we've got these different payoffs that are going to exist from this different combination of strategies between the 2 firms. Okay. The way that we'll depict this, and I'll give you some more examples with firms later. We're going to kind of set this up with like I want to say goofy example, but something that kind of shows you can use game theory in a lot of other areas, right? Decision making, not just like firm decision, but individual decision making. So the way we would set this game up is I've got firm 1. We're always going to put the first player on the left-hand side. I'll try to keep the numbers the same, so I'm not trying to trick you. Like person 1, firm 1, we're always going to think about that's the person on the left-hand side, and I'll explain why it makes it a little bit easier in a second how to do that. Firm 2 or person 2, we're always going to put on top of this matrix. Okay. We're then going to put what are the 2 possible choices these firms have to make? Well, they can set a high or a low price. That's firm 1's decision. Firm 2 can set a high or low price. That's firm 2's decision, right? The way that we're then going to pick this, if they both set a high price, here is firm 1's payoffs on the left. So using these kind of diagonals, you'll see this a lot like in the book, and if you like look at the different stuff in game theory, it's often depicted this way. At the end of class, I'll show you some other ways of depicting this that I tend to use a little more because I think it makes more sense. But the same rule would apply to depict it this way, or the way I'll show you at the end of class, which is person 1 or the left-hand side person's payoffs are always going to be on the left-hand side, or like the lower left-hand corner. Person 2's payoffs, the person on top, their payoffs are always going to be in the upper right corner. Okay. So these values in principle will be very different, right? If we both set a high price, profits might be high. If we both set a low price, maybe profits get down to the perfectly competitive point, which there are 0, right? So these values will all be different. So game theory is going to kind of allow us to identify from a game setup like this, what do we see? Do we see firms set high prices? Do we see one firm set a low price, the other firm set a high price? Where do we end up? What combination of strategies do we end up with? Okay. So I'll try to come up with some examples here, or a toy example before we jump into the prisoner's dilemma one. And now I probably got rid of those. I was going to say, let me keep my, yeah, here it goes. So this is a good one to kind of set us up. So let's say we've got a high price, and this probably won't mimic real world, but I'm going to use this example because I know that I don't have another example like this today, but it also makes a point for examples that we might look at in the future where this is the case. So I've got my normal form game. I've got each firm, and they're going to either set a high or a low price. If we both set a high price, we said, what are we getting closer to? Monopoly or perfectly competitive? Who sets a higher price? A monopoly market or a perfectly competitive market? So profit should be higher, right? So let's say we're both setting a high price. We get closer to that monopoly point. Sorry, this is both 20 million. If we both set a low price, maybe this gets all the way down. We're going to set that perfectly competitive price and we get 0. Okay. Now, what if I'm the firm that sets a low price while the other person sets a high price? What's going to happen to my profits? Well, it gets tricky. Because if I set a low price, what's that going to do to my total revenues? My price is lower, it's going to decrease them. But if my price is lower, what happens to my quantity? If someone else is setting a high price, everybody's going to buy from me. So let's just say in this scenario, I'm selling it at a lower price, but more people are going to buy from me. Okay, so profits end up going down. Would I want to do this? Probably not, but we can talk through that in a second. The person who's setting a high price, they're still operating, but nobody's buying from them. So let's say they have negative 10 million. And then person 1 is setting a high price. Person 2 is setting a low price. Person 2 gets 10 million. Nobody wants to buy from person 1 or firm 1, so they get negative 10. So the way that we're going to solve these games, and this is where I think writing them out will sometimes be helpful, because you can use your hand, but if you got a screen, you don't want to like draw on here. So I would usually write these out. You're going to figure out what both players' best responses are to the other person's, all their possible strategy choices. So for firm 2, if firm 1 sets a high price, so I'm like assuming they choose to set a high price, what should firm 2 do? Well, if they set a high price, they're going to get 20. If they set a low price, they get 10. So what do they want to do? If I'm trying to maximize profits, 20 is greater than 10 million, I'm going to set a high price. Now, what would they do if firm 1 instead set a low price? Well, if firm 1 sets a low price and I set a high price, I only get negative 10 million. If I also set a low price, my profits are what, 0? What's better? Losing $10 million or making profits of 0? Profits of 0. So I'm using circles to identify person 2's best response, their strategy choice, will depend on what the other person does. If firm 1 sets a high price, firm 2 will set a high price. If firm 1 sets a low price, firm 2 will set a low price. Now, I made these symmetric, so it's not overly interesting, but this is in case we didn't have symmetric games, this is how you would do it. We then will kind of say, okay, what is firm 1's best response to firm 2's choices? If firm 2 sets a high price, what should firm 1 do? Which of these is greater? 20 or 10? You guys are scaring me. I know that you're in college. I know you can compare numbers. Is 20 greater than 10? Yes. Are higher profits good for the firm? Yes. So they would choose to set a high price. I know it's early, right? What if firm 2 sets a low price? What should firm 1 do? Well, what's better, 0 or negative 10? 0. So here, firm 1's choice depends on what the other firm chooses to do as well. If firm 2 sets a high price, firm 1 will set a high price. If firm 2 sets a low price, it's better for firm 1 to set a low price. So anytime we have this is not a technical way of remembering it, but it'll always work for this class. Anytime you have 2 circles in the same box, That's representing a combination of strategies where what do these circles represent? Where the firm is best responding to what the other person is doing. So if we end up with two circles in the same box, it's a combination of strategy choices where we're both best responding to the other person's best response. That's our definition of a Nash equilibrium. We're both best responding to each other's best response. So in this example, notice how many equilibrium do I have? I've actually got two. It's actually going to be that we either see both firms set a high price or both firms set a low price. There's no incentive for either firm. Let's think about it this way. Let's say we were here. Well, if I'm firm two, sorry, what would I choose to do? Let's say we don't know what the other person's doing. We incorrectly guessed that they were going to go high. They went low. Well, I'm now losing $10 million. If I play this game again, what am I going to do? If I know they're going low, instead of setting a high price, what am I going to do? Set a low price. 0 is better than -10. So even if we ended up here, there's always going to be this incentive that pulls firm two away. Well, what if we end up here? What is firm one going to do? Well, they know if they instead of set a high price, there's always an incentive that pulls them away from that point as well. So these will never end up being the equilibrium because there's always incentives pulling us to these other two equilibrium. Now, if we're stuck in one of these equilibrium, is there going to be this incentive for us to for both firms to break out of this? Well, notice like for firm one here, am I going to go from setting a low to a high price? No, I'm not going to go from 0 to -10. That wouldn't make any sense. What about for firm two? I'm not going to go from 0 to -10. So we end up with multiple equilibrium. So that can happen. All the examples that we'll look at for the rest of the class, we're only going to end up with one. But I wanted to show you an initial example where we end up with multiple equilibrium and work through how we solve these, how we identify best responses, and what a Nash equilibrium looks like. Two circles in the same box, or we've identified that we're both best responding to the other person's best response. Okay. Any questions on this idea before we keep moving here? Yeah. Huh? So each box represents a combination of both firms' choices. The payoffs, I said, what are the bottom left payoffs? Who do those belong to? Bottom left hand side player, right? Or firm one in this case. What do the top right payoffs belong to? The player on top, or the firm two in this case. Yep. Any other questions? Okay. So what we didn't have in the example I just showed you is what we call a dominant strategy. So in my example, the firm's choices depended on what the other person does or did, and if they did something different, their choice would also change. A dominant strategy would be no matter what the other person does, I'm always going to keep choosing the same thing. So this is like a dumb example, but I always use we often have dominant strategies for sure when things aren't related. So if I took two of you and said should you study a lot or study not at all for the exam? You have two choices. What is it always optimal? Let's say the person next to you doesn't study at all. What's your best response to do? Study. Well, yeah, because that's what's in your best interest. You don't care what they study a lot. What's in your best response to also do? Study a lot, especially if you need to think about curves and So you always should be studying a lot for the upcoming exams. So you have a dominant strategy. It doesn't matter what the person next to you does. Your best response to whatever they do is always that you study a lot as opposed to studying. So there, you always make the same choice regardless of what the other player does. That's the definition of a dominant strategy. Your strategy choice does not depend on what the other person does. You always do the same thing. Okay. So if we both have a dominant strategy, like in my example, there's a dominant strategy for you to study a lot, a dominant strategy for you. So what equilibrium do we end up with? Everybody should study a lot, right? Doesn't matter, right? We all have a dominant strategy. We know what we're going to end up in. And we know that Nash equilibrium. And we'll work through some examples here in a second. Now, what can happen, unlike my studying example, because there you both study hard, hopefully that pays off in the exam, you both do well. We can end up with these scenarios we call prisoner's dilemmas, where dominant strategies push us to a Nash equilibrium where both people are going to be worse off. So the definition of a prisoner's dilemma is a Nash equilibrium where the payoffs to both individuals are lower than a different combination of strategy choices for both individuals. So we'll kind of look through some examples of this, and we'll talk through quite a few of these here today. Okay? So I've kind of got this set up, and I'll give you the normal form game here in a second. But let's say I've got two individuals, I don't know, bank robbers. This could also be, I set this up at like, instead of like jail time, could be like cheating and like whether or not you get like, I don't know, expelled or like academic probation. Well, let's just say we have two bank robbers. The cops, they don't have enough evidence to really put them away for the bank robbery, but they can get them on lesser charges. Okay. Did that just do something on the screen for you guys too? It was only me? Yes? Do you? I was gonna say, I don't know what that was, but we'll ignore it. So if we both don't confess, they get us on lesser crimes, we both get 5 years in jail. Okay. If they put us in separate rooms and we have to make simultaneous decisions without talking to each other. So this is like the setup of a normal form game. We're making decisions at the same time. I can't tell you what my decision is. You can't tell me what mine is or what yours is. So if I confess on my partner and they don't kind of rat on me or confess, I get to go away free and they put my partner away for, I think I did 25 years in the example here. Right? Yeah, there we go. 25 years. If we both confess, well, they can't let us both go free, but they now have enough evidence to put us away for more than just 5 years. They now put us both away for 10. Right? This is kind of the example of what we call a prisoner's dilemma. We'll use these payoffs to kind of understand why a normal form game matrix allows us to know that what's the Nash equilibrium going to be here? Everybody confesses. Right? So let's set this up. Right? I've got two players, Dan and Joe. I made Joe player one. He's on the left-hand side. So his payoffs are going to be on the lower left-hand side. Person two is Dan. His payoffs are going to be on the upper right side. Right? So if they both confess, skip ahead here. I don't know why I had those animations set, because if they both confess, they're both going to go away for 10 years. If neither of them confesses, they only get 5. However, what are the payoffs if Joe doesn't confess, but Dan does? Well, then Dan gets to go free, 0 years in jail, and Joe gets 25 years. If Joe confesses, but Dan doesn't, Dan gets 25 years, Joe goes away scot-free, right? 0 years. So I'll write this out instead of using it on the slides, because I think it's just easier to kind of use my hands and markers as opposed to trying to use things up there on the screen. So we've got Joe, we can confess or not confess, and I might shorthand a little bit of this here, but so we've got our payoff matrix. Now here it's a little bit weird. Because unlike my firm example, what were the firms trying to do? Maximize profits, so higher numbers were a good thing. Here, if this is jail time, what do I actually want? A lower number. Now, you could make these all negative and then look for the higher number. I'm not going to try to confuse anyone with negative. We're just looking now in this example for the lowest value. That's what's going to make each of these individuals better off, right? Less jail time. So let's first start out thinking about what are Dan's best responses to both of Joe's responses. So if Joe confesses, like let's just think of this scenario. I'm something like, okay, if Joe's in the other room and he confesses on me, what should I do? Well, if I confess, I get 10 years. If I don't confess, I get 25. So what should I do? My best response to Joe confessing would also be confess and rat him out. If Joe doesn't confess, well, then what should I do? If I confess, I get to go away for free. I don't get any jail time. If I don't confess as well, they get us on lesser charges and I get 5 years. So what do I want to do? Confess here. So notice for player 2, which is Dan here, anytime you have, not technical, 2 circles in the same column, that is a dominant strategy, right? Those circles represent best responses. So when player 2's best response is always the same, it doesn't matter if Joe confesses or doesn't confess. Dan's best response in both scenarios was to confess. That's a dominant strategy. Now we can think through Joe. Where Joe's, symmetric, so it'll be a little easy. But if Dan chooses not to confess, chooses to confess, what should Joe do? Well, if he confesses, he gets 10 years. If he doesn't confess, he gets 25. So he should confess. 10 years is better than 25 years in jail. If Dan doesn't confess, what should Joe do? Well, if he confesses, he gets to go away free, 0 years in jail. If he doesn't confess as well, he gets 5 years. So he's going to confess. So notice, regardless of what Dan does, Joe has a best response of always confessing, or a dominant strategy. So here's a scenario where we have both individuals have a dominant strategy to confess. So what is our Nash equilibrium? Well, I said an easy way to identify it, 2 circles in the same box, right? Which would represent we're both best responding to each other's best response. So here we have one equilibrium. Now, why is this an example of a prisoner's dilemma? Using a prisoner's example for prisoner's dilemma, because at this equilibrium, we both get 10 years in jail. If we could somehow agree to not confess on each other, what could we end up with? Only 5 years. So there is another combination of strategies where both of us would be better off. The problem is it's not an equilibrium. We know that we're going to end up at that combination of strategy choices where that Nash equilibrium is. So that Nash equilibrium would represent a prisoner's dilemma. Lower payoffs for both individuals. 10 years versus 5 years in jail for both. 5 years in jail for both. Any questions over anything I was doing there? Okay. All right. So, where are we at in time? All right, doing pretty good. What else do I want to say here? I think we can go back to the slides, maybe. Yeah, I'll go through this. We'll come back here in a second. So, I had this in the slides, but you work through it the same way. It's just, I have to throw my hand up over here, and it's kind of hard to see what I'm blanking out. But you're basically figuring out what each player's best response is to all the other possible strategy choices of the other player, which here we only have 2, right? So if Joe confesses, we said Dan will confess because 10 years is better than 25. If Joe remains silent, Dan confesses because going free is better than getting 5 years. And then if Dan confesses, Joe is going to confess because 10 is better than 25 years in jail. If Dan remains silent, Joe confesses because going free 0 years is better than 5. So we ended up with this Nash equilibrium, which represented a prisoner's dilemma, because if we could somehow both agree to remain silent or not confess here, we actually end up with less jail time. So we kind of end up with this Nash equilibrium of confess. I kind of already talked through. These are just kind of the bullet points of identifying that Nash equilibrium and what it tells us in terms of it being a prisoner's dilemma. So we'll talk through a more econ-y example in terms of firms' decisions, and it'll kind of have similar implications. So let's say we've got 2 firms and they want to act like a monopolist. Okay? So we call this like a cartel, right? We've got 2 firms and they're choosing output decisions where they're going to try to act collectively as a monopolist would. So I go over to firm 2. I've got T-Mobile and Verizon here, and they're selling to customers, and they both agree to sell to 30 customers. So what would if they're acting together as a monopolist, if both sell to 30 customers, what's the total quantity in the market? 60. So that 60 would represent the monopolist's quantity, right? They're trying to act like a monopolist together. They'll set the monopoly quantity, but there's now 2 firms, so they have to split that, right? And we're going to split it evenly. So I'll kind of give you a visual here of that in a second, but that's kind of where we're starting out. So if they act like a monopolist, the total quantity in the market is 60, each selling 30 units. Now, here, our strategy choices are, I can produce more or less. So instead of 30 units, I could produce or sell to 40 customers. We'll just use those two values for right now. You could make it, 30, 31, 32, and add a whole bunch of different possible strategy choices. The same logic will apply. We'll just use them too. So if I increase my quantity to 40, if both of us increase quantity, right, and we'll kind of see here the best responses. I'll build out the example here in a second, and this summary of it will make sense. If we both produce a higher number of units, what's going to happen to the price? We can get away with what in order to sell more units. What are we going to have to do to the price? I've got a demand curve. To sell a higher quantity, I'm going to have to lower the price. So, yes, I'm selling more units, but if I'm lowering the price, what kind of depends on am I increasing or well, is price still above average total cost? Am I on the elastic or inelastic portion of my demand curve? So in these examples, we can kind of think about if we both produce a higher quantity, well, now we're going to drive us down to a much lower price. That might not be optimal for profits, right? However, so we can kind of set this up in a normal form game, and I'll kind of write these out here in just a second, but we'll talk through why the payoffs would be what they are. And then I'll kind of, I think, try to connect this to what we were talking about last 2 weeks. So if we both restrict quantity, we act like a monopolist, the total quantity in the market 60, we're going to split monopoly profits. So monopoly profits would have been 1,800. Well, there's two of us, we're acting like a monopolist, so we split them evenly. We're going to be earning $900. Okay. Now, if I sell a little bit more, what did we say is going to be true about the elasticity of demand for where a monopolist chooses? Well, we know marginal revenue is going to be positive, right? If marginal revenue for the monopolist is positive, that twice as steep marginal revenue curve, we said demand must be elastic, which meant that if I increase quantity, lower the price a little bit, my total revenues are going to go up. So, right, quantity, because the quantity increase would more than compensate for that price decrease. Now, that helps out Verizon. If they produce more units, that's going to lower the price a little bit. So that small reduction in price hurts their total revenues, but the jump of quantity of 10 increases them. But what happens to T-Mobile? Well, now they have to sell at this lower price, but they're still selling 30 units. So what has to happen to their profits? Well, their total revenues go down, even if their costs stay the same. We know their profits are going to go down. Now, if they both produce more, this is where, okay, we're flooding the market with a higher quantity. We're not going to sell at a lower price. Maybe we end up with even lower profits. Right? So kind of think about what are we moving closer to when we're producing a higher number of units? We're getting closer to what equilibrium? We've only talked about two markets. So if we're starting out acting like a monopoly together, as we increase quantity, lower the price, we're getting closer to the perfectly competitive outcome. All right, those are the only two markets we've talked about up to this point. So let's use these values. So this was what? I forget. Let me make sure I line this. I think this was Verizon. Yeah, we had T-Mobile up top. Just drawing out what was on the slides. Hopefully I can kind of make a little more sense of some of this. So we've got 750, 1,000, 800, 800, 1,000, 750. So you can kind of think about what we're looking at here. This is where I probably should have saved myself a little bit more room. There we go. So if I have my demand curve, right? And let's just say, I think an example I'm going to use in a second. Let's do constant marginal cost. So marginal cost should reflect what? Supply. So where would the perfectly competitive quantity be? Out here, right? This would be the resulting perfectly competitive price. And at this point, we know profits would be equal to 0. Okay. Now, monopolists make a decision based off a twice as steep marginal revenue curve. So if we think about the monopoly quantity, Here would be the corresponding monopoly price, okay? So if we're both agreeing to work like a monopolist, we're starting out at this point. Marginal revenue is positive, so we know that demand is elastic. Okay? Now, when we set these quantities, we've got two firms now. So this quantity would be 60. Splitting it between two firms, we're both producing 30. Now, I don't know what quantity this would be. Clearly, it's not 80 because at a quantity of 80, we still have positive profits, but we're getting closer at a quantity of 80. We're getting closer to that perfectly competitive point. So what should be happening to profits? They should be getting closer to 0. So this is kind of where these come from. Oh, I can't quite keep all of this on here, but, well, at least I can. Hold on. There we go. So now we're going to go through and figure out, okay, will these two firms act like a monopolist, or will the incentives of even having a second firm in a market that has no barriers to entry, as long as we can have two firms, where are we going to see the equilibrium end up? So I'm going to first go through and figure out what is person one's best responses to what person two is doing. If T-Mobile sells at a lower quantity, what should Verizon do? Well, if they sell a lower quantity, profits are 900, higher quantity 1,000, so they should sell at a higher quantity. What if T-Mobile sells a higher quantity or to more customers? What should Verizon try to do? Continue to sell to 30 customers or try to sell to more? 800 is greater than 750, so they'll sell to a little bit more, right? Verizon, the left-hand side, player one's payoffs are the lower left corners. Is everybody with me on this? Okay. Now we're going to figure out what should T-Mobile do. What are their best responses to Verizon's choices? If Verizon sells 30 units, T-Mobile's payoffs are on the right or upper right. So what should they do? Sell 40 or a higher number of units. If Verizon is selling to more customers or a higher number of units, what should T-Mobile do? So what is my best, or sorry, what do both of these firms have? A dominant strategy. They always choose to produce a higher quantity, no matter what the other person does. So if they both have a dominant strategy to sell at a higher quantity, what do we know the Nash equilibrium is going to be? They both sell at a higher quantity, right? Or where are we both best responding to what the other person's best response is? Where are there two circles in the same box? Here at these higher quantities of 40. Now, why is this an example of a prisoner's dilemma? So even though there's not going to be the incentive that pulls them away from this equilibrium, if we could somehow agree to work together, what could our profits both be? Higher. So we end up in this Nash equilibrium where the payoffs to both people, both firms, is lower than a different combination of strategy choices. That's the definition of our prisoner's dilemma. Any questions on that? Want to see something again, or why did I circle something? Okay. Now, what could I continue to do, right? If this exists for the decision between 30 and 40, well, guess what probably exists for 40 to 50? It's always there's an incentive to be the one that sells to a few more customers, but because that incentive exists on both sides, it just keeps pushing us further and further, higher and higher quantities until we eventually get to where profits are 0. Now, I think I'll save it for next class so we can revisit this. What we end up seeing is it won't push them past the perfectly competitive point because if profits are 0, now if we increase quantity, what's going to happen to profits? We keep lowering the price even more, moving past the point where profits are 0. Now we're ending up where profits would be negative. Now there isn't the incentive to increase quantity. So we would kind of stop at that perfectly competitive point. But we'll talk through more a little bit. I'm just doing a one kind of 2 quantity choice example today. Okay. Okay with this? Any questions? Okay. So make sure I save us enough time. All right. So we kind of worked through this on the dot cam. I think it's just easier to kind of see, you have the slides to reference to go back. But here's our Nash equilibrium, which we said represents a prisoner's dilemma. What's another way of looking at this that also kind of helps us review a little bit from the last 2 weeks? Okay. So really, where did this come from? Let's say I had an example that looks something like this. Okay. If I'm thinking about a perfectly competitive market, price quantity represents my what? Combination of price and quantity is the quantity demanded, to be my demand curve. Okay. So we kind of looked at some of these examples last week where I have price quantity that represents my demand curve. I've also got kind of what those total how was I coming up with total revenue here? Simply price times quantity. And then if I wanted marginal revenue, how would I find that? It's the change in total revenue divided by a change in quantity. Notice, what's the slope of my demand curve here? Every time quantity goes up by 1,000, the price is falling by 10. For my marginal revenue, then, every time quantity goes up by 1,000, how much should my marginal revenue be falling? Well, it should be twice as steep. So instead of going down by 10, it should be going down by 20. Right? So this is just kind of using similar things we looked at last class as a demand schedule where we calculated total and marginal revenue. So where would the perfectly competitive market end up at? If I have a constant marginal cost of 50, it's going to be where marginal cost is equal to what? I had it drawn up here in the dot cam, where marginal cost hits or where supply hits it's a perfectly competitive market. Equilibrium is where supply is equal to demand. The demand becomes kind of like the marginal revenue curve, right? It's kind of like a price discriminating monopolist. We said for the price discriminating monopolist, if I can charge the price that exactly what consumers would pay, what does my marginal revenue curve become? The demand curve. Price discriminating monopolist gives you the same quantity as a perfectly competitive market. So where would marginal cost hit that demand curve for a perfectly competitive market? Right here, right? Where marginal cost of 50 hits my demand curve, that price of 50 would be at a number of units of 11,000. So if we had a perfectly competitive market, we know that we would be at a quantity of 11,000 and a price of 50. So if I had two firms splitting this evenly, they'd be setting a price of 50, but each one would only have a quantity of 5,500, right? So this would be like if we had these duopoly models, they get to that perfectly competitive outcome in the long run, they'd be splitting quantity in half, setting that perfectly competitive price. Now, if I solve this for a monopolist, so let's say they can collude together, what do I know has to be true about the price of a monopolist relative to perfectly competitive market? It should be, you answer this, the final's not going to go well. Monopolist can set a higher price, right? So I know it's not going to still be 50. Price of 6,000 seems a little wild, but probably A or C. So I'm thinking about a higher price. How can I identify what price they would set? Well, it's going to be where that twice as steep marginal revenue curve is equal to this constant marginal cost of 50. So where would my marginal revenue be equal to 50? At a quantity of 6,000, right? So the monopolist is going to set that quantity at 6,000, which compared to the perfectly competitive market, not only should they set a higher price, they should be setting a lower quantity. Sure enough, they do, right? Now, how do I figure out the price is 100? Well, it's at that quantity. Where am I at on the demand curve? Well, that's my combination of price and quantity. So at a quantity of 6,000, the price the monopolist would charge would be $100. Okay. So higher price, lower quantity with a monopolist. So if I have a duopoly where there's two firms and they're acting like a monopolist, the price they'll set will be 100, but how much would each firm be producing? If we act together and produce 6,000 units, there's two firms, each firm would be producing half that, right? You identify that You identify that profit maximizing quantity for the monopolist. And then if you have these duopoly models where we're agreeing to act like a monopolist, we're going to produce that quantity totally. So that means we'll split it evenly. So if we're producing 6,000 as the profit maximizing quantity for monopolist, we'll each produce 3,000. Questions on kind of how I'm identifying this, kind of thinking about the markets we've already talked about. Duopoly's acting like a monopolist here. Yeah. Yeah. So if we're acting like a monopolist, we should set marginal revenue, this twice as steep marginal revenue curve, equal to marginal cost, which would be constant at 50. I gave you a constant marginal cost to make it easier. That's at a quantity of 6,000. If we have a duopoly model, they would then, two firms, total of 6,000, each firm would be producing 3,000 units, or 6,000 divided by 2. Does that answer your question? Any other questions on this before we keep moving here? Okay. So once again, we did a lot of this last week, right? Looking at these demand schedules, coming up with total marginal revenue, identifying profit maximizing points. The only caveat is here with a duopoly model, we identify that profit maximizing point for the monopolist, and the quantity gets divided by 2 because we have 2 firms. Okay. So for next class, well, I think I might save this for next class, but if we start out in the scenario where both firms are producing 3,000 units at a price of 100, instead of thinking about quantity decisions, let's think about prices. If there's 2 firms, why might I want to lower the price? If I lower the price, what happens? So there's 2 firms, let's say we're both charging $100, acting like a monopolist. As a result, we're both selling 3,000 units. If I lower my price, what happens? Consumers will all want to buy from me, right? In fact, everyone's going to want to buy from me. So I might lower the price to 90. And yeah, I know that at a lower price, I'm going to sell a few more units. But maybe not only do I go from like 3,000 to, maybe I only sell, maybe lowering the price really hurt my total revenues and I didn't sell that much more. But everyone that was buying from the other firm now comes over to me. So I might go from like 3,000 units sold to like 7,000. And even though I only had to lower the price by $10, right? So I lower the price by 10, quantity market 7,000, but everybody wants to pay the lower price, so everybody buys from me. So firm one's profits are definitely going to go up. Firm two's profits become, well, they're not selling anything anymore. So even if they stay open, they're going to have some cost. Their profits are now going to be negative. So there's this incentive to be the one firm that lowers the price because I can increase my profits, right? Well, now if the other firm lowers the price and I didn't, we said their profits would be negative. So what am I going to want to do? If I want to stay in that industry, the other person lowers their price, what do I have to do? Lower the price as well. Now, if I lower the price to 90, well, now we are both splitting demand evenly. Now I'm selling 3,500 units. But at a certain point, that price reduction, yeah, we're selling a few more units, but where does that start to hurt my total revenues? When demand becomes inelastic? Or maybe even though I'm seeing total revenues go up a little bit, it's not going up as much as my costs are. So there's this kind of incentive that we're each going to want to undercut each other's price. But what does that do? It moves us to lower and lower profit levels. Eventually, we get to the point where we're both charging 50. At that point, what are our profits? Well, what did we say that point of 11,000 was? That was the quantity in the perfectly competitive market where profits are equal to 0. Price is exactly equal to, if we have constant marginal cost, then the marginal cost essentially is our average total cost. So there's this incentive for each firm to kind of keep undercutting each other's price until we get to where profits are 0. Now, if I undercut the price even more, now my profits are negative, so I don't want to do that. So there's always this incentive that pushes these firms to undercut each other's price all the way down to that perfectly competitive point. And I'll work through some more normal form kind of depictions of this next class. I'll bring in some, but I just want to at least talk through kind of the logic of it here today, based off of what we've talked about, comparing monopolies to perfectly competitive markets and the incentives that would exist. Okay, so I won't focus too much on this, but the idea here is we know that oligopolies, as long as we have a second firm, there has to be more competition. There's two instead of one firm, right? So this idea that there's more competition, this is the idea, oh, I want to be the one that's selling at a slightly lower price, right? So that just that small amount of increase in competition, that I want to be the firm that has a lower price relative to when there was only one firm and I didn't have to worry about anybody, just that amount of competition will drive us all the way down to that perfectly competitive outcome. So when we're talking about like the difference between a monopolist and a perfectly competitive market, it literally can go from 1 to 2 firms, and we're at that perfectly competitive. Now we'll talk about some things that might complicate that next class, but that we can see that happen. Oligopoly profits are going to be lower than perfectly competitive. Now that one's probably, I mean, probably not going to last. If we're looking for which one definitely won't last, that's not going to be it. We'll talk through that one a little bit more. I kind of jumped the gun a little bit with this slide. I'm going to work a little bit out of order. But oligopoly profits, even though there's this incentive to kind of undercut the price, there's not enough competition to where we usually do get driven all the way to the perfectly competitive point. So you can think of it as like a continuum. Where are profits at their highest? If we work together and act like a monopolist. Where are they zero? Perfectly competitive. The oligopoly, there is going to be some of this competition that undercuts the price, but it's likely going to push us to a point somewhere in the middle. It's probably not going to push us all the way in practice to a perfectly competitive outcome. So we'll still have profits where we have these oligopolies where we have 2, 3, 4 firms. We'll probably still be positive, right? And then, so we have increased competition, profits are still a little bit higher. If oligopolies, firms know that oligopolies are often illegal, so they break the deal to escape. That's, we see some regulation of oligopolies, so trying to work or collude together, we often see that that's not going to play out, because if the government's going to come in and remove you from the market, what do your profits go to? Zero, right? So the one that we kind of have here, the dominant strategy is that we break the agreement. That was what we just worked through with our game theory, where we said there's this idea that I always want to undercut the price. Even if I agree to set a higher price and agree to act like a monopolist with the other firm, there's always this incentive that pushes away from that point. Okay? So we'll revisit this next class. I'm going to skip ahead a little bit. I've got some stuff that we'll go through here, but just before we get there, here we go. I just want to talk through some examples to kind of give us an idea of like how we see this play out in the real world. And we'll revisit the prisoner's dilemma with one more example to start next class. And I think I'll have time. I might depict one of them here for you in a second. So let's think about ad wars. So let's say, I don't know, the city of Bloomington, let's go Elliston. You guys probably don't know if there's on. There's a place called, see if I can even remember, Pizza Pantry, I think is what it's called. And then there's another pizza place called like, I don't even remember the name of it. 2 pizza places, right? They don't run local ads. So nobody knows. So the only way you know is if you're driving through and you want pizza in Ellisville, you're going to stop at one of those 2. So we don't spend any money on ads. We're on different sides of the highway. We probably evenly split demand, right? Well, that's kind of weird scenario. But well, what if I start running local ads? And now people in the area on radio, TV, they start to know that I exist. So what am I going to get more of? The demand, right? I have to change my price. I'm just going to get more demand, right? So if I run ads, I can increase the quantity of selling. Well, I had to increase my cost a little bit to do so. But if I'm the only one running ads, everyone now comes to get pizza from me. I'm going to increase my revenues a lot and only have to increase my cost a little. Now, the other firm, if they don't run ads, well, they're going to sell a lot less. So what is there an incentive for them to do? The other person is running ads. They want to also run ads, right? Now we're back to, we spend the same amount of money on ads, we're splitting demand again. Right? Well, now what does one of the other firm do? I want to spend a little bit more on ads to grow. Well, what happens? We end up in this kind of spending war where we're spending a ton of money on ads. We're still splitting demand. Revenues haven't changed, but what have we increased? Our total costs from ads, right? So the prisoner's dilemma, with the ad wars, we see companies spend a lot of money. It's always better to be the one that's spending more on ads, but that incentive exists for both firms. So we end up with a Nash equilibrium where both firms spend a lot of money on advertising. We're still splitting demand evenly because we're offsetting each other's ads. But what did we do? We increased costs a lot. So profits could actually become negative, or at the very best case scenario, closer to zero. So this is a prisoner's dilemma, because if we could both say, hey, look, I'm not going to run any ads if you don't. Well, now we're still splitting demand without all the additional costs, right? But there's always this incentive to be the one that breaks that agreement. So we see ad wars as a good example in practice of prisoner's dilemma. OPEC, right? So if you're trying to act like a cartel, and kind of set higher prices, restrict quantity, there's always the incentive to be someone that we've just worked through, like that breaks that agreement. So what's one way we see this protected? So all these companies that belong to OPEC, and they're making like export and production decisions in terms of gas, not gasoline, but oil. If I break the agreement and OPEC says, as soon as you break the agreement one time, you no longer can be part of our organization. What did they just impose on that firm? A very large cost, right? They're no longer able to ever be a member of OPEC again. With that additional cost, maybe now it isn't profitable to break the agreement in one period if on every other subsequent year, I'm no longer going to be able to be a member of OPEC, right? So you can kind of think about a similar thing would exist. Let's say we had firms and they were working together like a monopolist, and we're sharing like cost-cutting techniques. You're like, look, we're all sharing our trade secrets, but as soon as somebody starts breaking the cartel agreement, we're no longer going to share all of our new technology with you. Well, now that firm where there used to be incentive to break the agreement and earn positive profits just in that one time period, well, now in subsequent time periods, if they're no longer going to get any of the additional technology information, what did I just do to their cost from here to perpetuity? I've made them higher than every other firm in the industry because they're not going to be able to advance their technology as much. So the only way we kind of see this prisoner's dilemma break down is if we have some type of additional cost that can be imposed that protects against us going to that Nash equilibrium, or that prisoner's dilemma Nash equilibrium. Okay. Other examples, so I've got common resources, arms race. I think these make a lot of sense. So like if I say I have two countries, and let's say they're spending nothing. I have two choices: spend nothing on my military or spend a lot. If we both spend nothing, what's the cost? Zero. Anyone get attacked? We don't have military. I mean, if I spend nothing, what's my military? Doesn't exist. So can anyone attack each other? No. All right. So we both spend nothing. There's no benefit in terms of like, sorry, I shouldn't say there's no benefit. No one attacks each other and we have no costs, right? The benefit is high. Like this is good, not more. What if I break that agreement and I'm the country that spends more on my military? Well, I had to increase my costs, but what can I now do? March over to country B and say, give me all your shit, right? I mean, this is like not how we see things play out now because everybody has military, but back in the day, like if I'm thinking about like a very rudimentary example of tribes, if I have military, I'm going to come take your stuff if you don't have it, right? So we see this happen with a lot of cultures where we came in, they didn't have like the military prowess, and we just took all their stuff, right? So there's an incentive to be the one that has military when someone else doesn't, because I can now take all of your things, I'm better off. So if someone else has a military, I know they can just come in and take all my stuff. What do I want to do? My best response is to spend money on my military, be able to combat that. Now that we both have a strong military, what can I no longer do? Now that you have military, I'm not going to come over and take your stuff because I know that's going to start a war. So what do we see happen? Countries just start spending more and more because there's always an advantage to be the one that has a little bit better technology militarily, a little bit larger of an army. So what do we both have an incentive to do? Keep spending more and more in our military. We end up with a scenario where we have an arms race, right? Everybody's spending a bunch of money on their military, but notice, so the cost went way up. What's happened in terms of the benefit? If everybody had a strong military and the threat of you invading someone was that you'll end up in this decades-long war, what do people don't do very often? Like since World War II, high powers, right, countries that have huge militaries, what have they not done directly? Attack each other, right? So we're back to the scenario where if we didn't have militaries, what do we say happens? Nobody attacks each other. So the benefits are the same. The costs are now astronomically higher. We're worse off. We have a prisoner's dilemma. So arms race is another good example of a prisoner's dilemma. You can, excuse me. You can also think of a common resource as a prisoner's dilemma. If we all have kind of like a common resource, like fish in a pond, we all agree to only catch one fish a day. Well, there's always an incentive, like I'm kind of hungry. I want to actually have two fish today. But if we all catch two fish, what's going to happen to the number of fish available tomorrow? The population can't keep up with itself, so it's going to go down. So negative externalities are also situations where we can see prisoner's dilemmas exist. If everybody catches a second fish, now the population of fishes goes all the way down to 0. Are we all worse off or better off? We're worse off. The fish population is now gone. So the idea there being common resources, a lot of the times we see that they fall victim to this prisoner's dilemma, and we're driving the amount of that common resource that's available closer and closer to 0, which is worse off. So what do? We try to impose legal restrictions that if you get caught fishing and you catch more than 2 fish, what do? Revoke your fishing license, kick you out of our town so you can't fish in our pond, right? We impose these additional costs because if you start to break this agreement that we had, or we know we'll end up in this prisoner's dilemma Nash equilibrium where everybody's worse off. But without these additional legal restrictions, we would see common research. I mean, we saw it happen, right? When there was no restrictions on hunting buffalo, what happened? Drove the buffaloes down to 0, essentially, right? All right. So some of the kind of examples we would see, we'll kind of revisit this, right? Thinking about prisoners' dilemmas. I've got another example with attack ads that we'll kind of look at next class. And then we'll kind of talk through why they might cooperate if we have multiple time periods. And I'll show you a couple different games. And then we've got sequential games for next class as well. So we still have a good amount to kind of work through next class, although I don't think this will take us probably even the entirety. We might have some time to work through some practice problems. But what I want to do for the remainder of the class is publish this quiz. So under module 12, we'll kind of talk through. Oh, where is it at? Oh, there we go. I got to build. We got here 10:50. So preview. All right. So I want you guys to try to work on this for a little bit. I will kind of work through these with you, so don't worry about getting the answers right or wrong. I'll eventually give you what the correct answers are. But I think there's some value in you attempting it and then seeing me work through it as opposed to just watching me do these. So I'll give you guys the next 5, 6, 7 minutes, kind of work on these. So you've got 2 games where I'm just asking you to identify the equilibrium. Don't worry about this third one. I'll talk through this one with you. But for these first 2, try to take a stab at them. Now, I'm giving you these in a slightly different way than what we talked about today because I might use either example on the quiz or on the exam. So instead of using these like diagonals, where I can get that a bit confusing, I think it makes sense. Person 1 or the left-hand person's payoffs, just to put those on the left. So, for example, if they both cut fares, United's payoffs would be on the left at 400. American's payoffs are on the right at 400. If United cuts fares where American doesn't, United's payoffs are 800. The left-hand side person's payoffs are on the left-hand side. And the person on top, player 2, their payoffs are still on the right-hand side. So it's still lined up with, if we look at these normal form game matrices with the diagonals, the person on the left, their payoffs are on the left. The person on top, their payoffs are on the right. And then you would solve them in a very similar way. So I'll give you guys a little bit of time to kind of work on these, and then we'll kind of come together and talk about them. Okay? Let's see here. Talk to the people around you, do whatever you want. You don't have to be silent. People who are worried about their grade, who email me or want to come to office hours, trying to work through these on your own and just instead of just relying on me to work through these to get the correct answer is always a good way of trying to build your skills and knowledge of these things. So that's why I'm giving you a little bit of time to work on these. Also helps you understand what you don't know. All right. So in this first one, does anybody identify what the Nash equilibrium was? So when we identify Nash equilibrium, we're thinking about what strategy choices were made by United and American here. So what was the Nash equilibrium that was identified? Nobody got it? Yeah. Yeah, so the Nash equilibrium ends up being that they both cut fares. So before we solve for that, what would that be an example of? If they both cut fares, the payoffs are 400 for each. So what is that also? If that's our Nash equilibrium, we have an example of a what? Well, what if they both didn't cut fares? Their payoffs would be 600. So this would be a Nash equilibrium that is an example of a prisoner's dilemma. So how would you solve for this? If firm A, or whatever, American, cuts fares, so that's the decision they make. Remember, the person on the left, that first person, their payoffs come first. So what should United do? Well, which of these numbers is higher? These represent kind of the payoffs to United, profits, revenues, whatever you want to think about. Which of these would be preferred? Does United want higher or lower profits? Higher. So we would cut fares. Right? Now, what if American doesn't cut their fares? Well, now if I cut my fares, I sell at a lower price, I increase my profits to 800. If I don't, I'm only going to have profits of 600. So what am I going to do? Cut my fares. So United would have a what? Cutting fares for them would be a dominant strategy. They keep doing the same thing regardless of what the other player does. If we then think about what is American's best response to United, if United cuts fares, what should American do? Well, 400 is greater than 200, so they should cut fares. What about if United decided not to cut fares? Well, if they don't cut fares, they get 600. If they do, they get 800. Here we would say American has a what? Dominant strategy to cut fares. Once again, non-technical way of remembering it, but like, where do we have two circles in the same box? That's where both players are best responding to what the other person is doing, right? There's no incentive for firm one to not cut fares, and there's no incentive for firm two not to cut fares, okay? Any questions on that one before we keep moving? We only got 5 minutes here, so I might go just a little bit quicker. Now, we basically do the same thing here, but I actually constructed one where I've got someone who cares a little bit more about working hard and someone who just doesn't want to get fired. That's how I align these incentives. So shirking is just another word in economics for like you're slacking off. It's just a word that's used in economic literature, like going back to like the 20s. I guess it was like a more popular term, and it just kind of stuck. So working hard or basically not working hard. So if person two works hard, I always think of, I used to be a grocery stocker, and I worked with some people in the back that like didn't give a shit about their job. And I felt like I always did all the work. So we'll see what that happens here. So if person two is working hard, what should person one do? Work hard or shirk or slack off? Work hard. What if person two is deciding to slack off? What should person one do? Well, they have some intrinsic value of making sure the job gets done, so they're going to work hard. What about person two? If person one is working hard, what is it actually? These represent like utility maybe to the consumer or to the workers. What is it actually optimal for them to do? Slack off. They know the other person's going to do it. They don't care, right? They just care the job gets done. They don't get fired. So if you're going to do it, they're just going to slack off. Now, if the other person doesn't work hard and the job's not going to get done, we'll notice here, what is it optimal for person two to do? Well, work hard. I don't want to lose my job, right? So here, person two actually has a non-dominant strategy, while person one always has a dominant strategy. What is our Nash equilibrium? Here, person one is going to work hard. Person two is going to slack off, right? So the person that didn't value working hard, right? They just cared about not losing their job, right? Kind of result in this Nash equilibrium where person one works hard, person two doesn't. Okay. And then you could kind of work through this one relatively quickly, but this is really, we've already looked at examples of this. So if firm two sets a high price, what should firm one do? Set a low price, right? Their payoffs are on the left. If firm two sets a low price, what should firm one do? Also set a low price. If firm one sets a high price, what should firm two do? Well, their payoffs are on the right, so they should set a low price. If firm one sets a low price, what should firm two do? Their payoffs are on the right, set a low price. So what do both of these firms have? Dominant strategies. However, this Nash equilibrium, the payoffs are actually lower than if we could both agree to set a high price. So this would be an example of a prisoner's dilemma. And I think this one you're looking for what's not true. So we had what? They both cut fares will be the equilibrium there. Person one worked hard. Person two shirks or slacks off. Both firms have a dominant strategy to set low price. It's an example of a prisoner's dilemma. Firm two and firm one will not cooperate to set a higher price. That was the idea that, yes, they won't, right? This is a prisoner's dilemma because they can't agree to set a high price. There's incentives that push them towards this Nash equilibrium where both their payoffs are going to be lower. So the only one that's not true there is going to be Nash equilibrium. This equilibrium results in maximum profits. Where would their maximum profits actually be? If they could somehow agree to set a high price, which that wasn't the Nash equilibrium. We said the Nash equilibrium was for them both to sell. Yep. Hold on. So yeah, what's the correct answer for number three? We're looking for which one's not true. You guys don't be quiet. Somebody's going to get it wrong. So I'm trying to help you out. So I'll get 3 points. What's the correct answer on the third question? Yeah, the equilibrium maximizes profit. That's not true. If we have an example of a prisoner's dilemma, we know the payoffs are going to be lower at that equilibrium than some other combination of strength. Okay? All right, so get that submitted before you leave. I have it set to be due like a minute after class. Otherwise, we'll see you guys on Thursday.